like to thank everybody for coming out to our seminar and to those people who are linking through the video stream. Anyway, it gives me great pleasure today to have Jean-Francois Cloutier up here speaking about Agile development, software development. I heard him give a talk at the MESDA annual conference in Portland. I thought that what he had to say was very interesting, and that we up here at the University of Maine should be more familiar with this movement. Jean-Francois is a partner in a company called Information Weavers, okay? And they have some interesting ideas about sort of alternatives to grid computing and various other techniques. He's worked on a fair number of large software projects. And so without further ado, I'll let him tell us about Agile software development.
Thank you, George. Thank you for being here today. Agile development, doing more with less. We're going to be talking about the fact that bloat is really hurting software projects, and that there is an alternative. There's a way of counteracting this tendency, and it's called Agile Development. We're going to go into some details as to what is behind Agile Development and a number of technologies that I think are very promising for really bringing our productivity much higher in software development and really cutting down on failures, project failures. If we have some time, they're going to do a bit of a show and tell. At Information Weavers, we've developed a Agile integrated development environment. Well, it's really we coupled together a bunch of tools from the open source movement and made them talk to each other. And it provides for a very, very nimble environment in which to do collaborative development, especially when the team members are not co-located. And we're going to talk a little bit about MADOG, Maine's Agile Development Users Group, which is being set up as we speak. Now, you may have seen this picture. This is a 1954 RAND Corporation, obviously at a trade show. They were demonstrating what they thought the home PC would look like 50 years hence. This is their idea of the...
I like the steering wheel.
Well,
that's for games.
The relative who sent me that picture made the note that it's probably the ancestor to the mouse.
Yeah.
Now, but before you think you laugh, it's very funny. Let's look at how we do software development today and see if we're doing much better. I'm going to tell you a few stories, things I've seen, been involved in, train wrecks I've witnessed from way too close. Down the waterfall. It was a large project, a big financial institution, rebuilding their big financial system, which had been grown organically over the years. And they were redoing it pretty much from scratch. And it's a 2-year effort. Very close to the end of the second year. It's a couple of months before initial release, they say, oh, maybe we should start testing. And as they sit down to start writing the test, they realize, gee, we don't have formal end-user requirements to do acceptance testing from. So 2 months before release, they started doing formal requirements analysis.
By the way,
yes.
Winston & Rice's original diagram had feedback all the way through it. The first time somebody copied it, they removed all the feedback. And that's the one you see in the books.
Okay. Recipe for disaster. An insurance company, large insurance company, wanted to do a web application framework to use throughout their different projects. And I was asked to look into it and see, what did I think of it as an architect? And I said, okay, what's the heart of it? It's the servlet. People familiar with Java web applications. I looked at the survey. It was 4,000 lines of the most atrocious spaghetti code, breaking all the rules and inventing new rules to break. And this was supposed to be the heart of a corporate web application framework. The never-ending methodology. Well, big project, big team. They're bringing in 100 consultants into this project, and they decide that they were going to do it right. That it's going to be a methodology, no ad hoc programming. So they had a methodology group. Everybody in the methodology group was the first introduction to methodology at all. And so they looked at all the different books and read all the different methodologies and decided to take everything from every methodology that they liked and create their own homegrown methodology and everything but the kitchen sink methodology. And they kept revising and building that methodology as the project was ongoing and publishing it revisions every 2 or 3 months in a big 3-ring binder. Something's wrong. Company in New Jersey asked us to build a framework on top of EJB. If you're familiar with the Enterprise Java Beans, it is a framework. And they wanted us to build a framework on top of it because they felt that EJB was too complicated for the type of programmers they were going to outsource the development to. Pure nonsense. Something's wrong. The plan that ate its own project. Again, big project, and the manager is risk averse. He wants to know how things are going to happen down the road. Wants to know who's going to be doing what a year from now, down to the day. So, big project office comes in, 12, 14 people from a consulting group, and what they want to build is this incredible project plan. So they grab every project lead. By the way, each project lead was the only person who actually had written significant code before in his life. So they grab every leader and say, okay, you're going to work with us and build this incredible project plan, very detailed. And every time actuals went against plan, they had to readjust the plans. And now, these are all different pieces of plans coming together. And if there's any inconsistency, it has to be fixed. So writing the plan became the overriding project. And that's when I realized that project plans are like cocaine to project managers. It's addictive, and they give it more importance than the actual project itself. Room-sized UML diagrams. I'm talking about a relatively small room here, I must say, but nonetheless, the whole idea was, before we do any coding, a very disciplined bunch of people, before we do any coding, we're going to diagram it all. Whole sequence of calls and what piece of software gets called, what gets returned, all the way down to a very, very impressive level of detail. So I'm into this room as an architect, and the guy says, okay, we're going to show you where we're going to be writing. And they come in with a big printout, but it's all scotch taped so that it unfolds, put it against the wall. So you have this UML diagram that stretches from one wall to the next, saying this is what we're going to do. Now, let me tell you, this is not what they did. And of course, revising this document was more expensive than writing any code. Eventually, the whole practice disappeared. But there it was, room-sized UML diagrams. I've seen it. It's there. It exists.
Yeah, it's the Soviet Union's economy. It's like that.
And you wonder why
Yeah.
things go wrong. Well, I'm starting to feel uneasy about the way things are going. Maybe I've been unlucky. I've been on difficult projects. Only today, because it's streamed. I have a few questions. I mean, don't you feel detailed documentation is really hard to keep up to date? It feels to me like a quart of milk, with an expiration date. So what's the value of it when it's so hard to write and so hard to keep up to date? Eventually, your documentation becomes a pack of lies. Okay, those heavy-duty methodologies where you feel like you've got this disciplined army in front of you, everybody, describing in great details what they're going to do, maybe, eventually, one day. To me, I feel like it's really there to comfort management, not to get software out of the door of any quality whatsoever. It's management cocaine. For those who know Enterprise Java Beans, that's a big framework that was written before any actual coding experience. It was like, we anticipate this is going to be very useful and it's going to solve very hard problems. Well, it still feels today like a very flawed solution, not one inspired by, instructed from experience. And it's really still looking for that really big problem for which it's just right. If you've been trying to keep up to date with all these XML, Java libraries, or all these different methodologies coming out, it's getting harder. There's so many APIs, libraries, etc., in very limited time, and very little brain cells as well. Now, project plans. I've rarely seen a project plan that's useful. Or maybe they are useful, because I think they're used mostly to lay guilt trips on developers. But you said last year you'd be done this week. What's going on? You lied to me. So something is wrong. There's a misuse of methodology. The tools are inappropriate. Things are out of control. Bloat factors.
Is that the mascot for Microsoft?
That's the University of Minnesota.
Well, I'm sure this guy sees a shadow any time of year. Featureitis. You look at software from big companies, the web spheres of this world. It's a competition. I mean, my features list is bigger than yours, so buy me. And you end up having software that is so complicated that you have no choice but to hire the consulting services of the vendor. Well, maybe that's the point. So there's a big problem here. Things are getting too big, too complicated. There's a drive to make things overly rich to compete and to probably justify very high license prices. Methodocrats, well, they don't care about software at the end. It's the documentation, and they want lots of it. These guys are bloat factors. What I call the ratchet mindset, and I've seen it many times. If every time you write code, you're not allowed to go back and fix it or change it if it works, management says, well, does it work? Yeah, but I want to change it because it's too big. I found a way to make it much smaller and make it understandable. Does it work? Yes, it does. Don't touch it. I want you to develop new functionality. I want this project to move ahead. Well, the ratchet mindset means that you're just building too much code. It's getting out of control. And when you know how you could actually go back and make it simple, elegant, you're not allowed to, well, it's a bloat factor. Another thing, another factor that bloats software is what we call the prophetic coding. It's coding today for problems you anticipate tomorrow. So you start writing too much code that you say, oh, but if I'll do it now because I know it's going to, I think I know, I'm pretty sure I know, it's going to be useful a month from now, a year from now. We probably will want to move to, be able to move to an object database. Right now we're in a relational, so I'm going to write it this way. Or maybe we want to have more than a web front end. We'll want to have a fat client front end. So I'm going to anticipate that need. But that need may never come. And what you end up is writing a lot of code in an anticipatory fashion that just serves no purpose today and creates a maintenance burden forever. So that's bad. I call you've heard of the golden hammer. Well, the golden jackhammer is even bigger. Examples of web services is really big. I mean, it's a very, very fashionable thing. And then what you see is people coming in and saying, well, let's just put web services everywhere. Or let's have every piece of software, talk to every piece of software using XML, for example. It's like you have this wonderful tool and you want to apply it everywhere. But it just bloats your solution. Code weed. We'll see that a bit later, is when you have these frameworks like EJB that you want to use, but the price of using them is that they invade your own code. They force you to write a lot of code to support them. And what happened is that you want to write something relatively simple, but because of the framework you're using, you have to write a lot of code that sometimes does nothing. It's a very invasive framework, another factor of bloat. Okay. It really is a problem. It really is a hurting. I've seen it, I've been there, and it's a problem. In reaction to this, there's a movement that's afoot. It's called the Agile Alliance. And what it wants to do is do more and do things better, but with much less. Let's just cut through the fat, cut through the excess, and just try to understand what is really needed, what's minimal to achieve the goals at hand. So they're coming up with a set of very nimble practices, nimble in the sense that it allows you to react quickly to changing conditions. And a bunch of technologies also which are just right for what you want to do, but no more. And they came out also with the Manifesto of shared values. So it's really a movement of ideas and attitude and a new way of looking at software development. I encourage you to go and check the Agile Alliance website. Who are the leaders? They're not academics. They're not vendors. They're actually software developers in the field saying, okay, we think we've noticed some things going wrong. We've noticed that certain things do work. Let's try to conceptualize what's working, and let's try also to communicate our experience to as many people as possible. So it's really a loose confederacy of programmers, very disciplined, very talented, and extraordinarily pragmatic. They care. They really care about delivering business value. Actually, they want to move out of the way anything that stands in the way of delivering that value. They want to understand what really works and why it works. So they care about their craft. And they don't believe it. In sacred cows, they don't believe.
Okay. Can you ask a question?
Sure.
Yeah. Are there any companies that we might recognize in the software industry that are prominent or present in the Agile Alliance, or is it really just a bunch of ad hoc?
There's a bunch of individuals. There are companies that supply tools and that are congruent with the Agile Alliance's goals. There are names that are well known in the field. For example, Kent Beck is probably one of the leading proponents of Agile Technologies, and he's helping different companies to come up with the software that really is in line with the thinking. We'll look at a few of them, but you'll find most of these tools to come from the open source movement. That's really where you will want to look. So I'm just going to read quickly through this. I think it's worth carefully going through the words. So here's what they say. We are uncovering better ways of developing software by doing it and helping others to do it. Through this work, we have come to value individuals and interaction over processes and tools. Processes and tools are important, but they're not as important as individuals and interaction. So the thought that you can take a software methodology and say independent, more or less, of the people that are going to be working, we guarantee a certain degree of success. Well, that's wrong. They value working software over comprehensive documentation. Put the working code as higher up than doing good documentation. So that's how you recognize that a project is successful, not that it's coming out with wonderful documentation, but first of all, it's producing working software. Doesn't mean that documentation is not important. It's less important. Yes?
What you said is different from what that said. It's putting software ahead of good documentation. They're saying putting working software over comprehensive.
Yeah, you're right. Comprehensive.
And that's the issue.
Yes.
The issue is the Victorian novel documentation versus minimalist documentation.
Yes.
And then there's good versus bad.
Yes.
I just wanted to
I agree.
clarify
It's a
that.
question of volume
Yes.
and detail level.
Yes.
I agree. Customer collaboration over contract negotiation. Don't try to predict all possible ways in which the project may change. Don't try to fence in the client. Come out with a good modus operandi and work with the client as the needs evolve. It's a collaborative process, but don't try to fence in the client. Responding to change over following a plan. Well, Agile Development considers change to be inevitable and a good thing. So don't try to come up with a process that says we're going to anticipate everything and then try to avoid change, or if change happens, we'll try to, the process will become very brittle. So come up with a process that considers change as a given and responding to it as a high value. Well, that's the manifesto. A few principles. Well, emphasize early and continuous delivery. Don't deliver software the first release 6 months down the road. Deliver at least, monthly, if not faster, and continue to deliver so that you have this very, very tight feedback loop between what you're doing and what the client wants. Welcome changing requirements. Don't say, well, I don't want to hear about any new requirements or change in requirements. This will have to wait in 6 months. No, just build it into your process, the fact that new requirements will come in all the time. Of course, you've got to be extremely disciplined about it, but you do want to welcome them. It also says that business people and developers work daily together. In my experience, projects that I've worked, I've mentioned the projects I've been in that really work. They were small projects where we were working in the same office as the clients, and the clients would come in and walk through the development area, and we would chat all the time. There was no every 3 months we'll go back and do a reality check. It was a reality check every day. The most efficient way of communicating is face-to-face conversations. Don't go with methodologies where you throw documentation over a wall for another team to pick it up. The amount of information, real information, useful information that you can convey in a document is limited, especially when you're in the middle of solving a difficult problem. Face-to-face conversation, every day, meeting together and talking together is much more productive. Yes?
Well, I'm just trying to figure out the causality here. It seems to me that because of these principles, you're pretty much pushing the software development project to be of a smaller scale than we may otherwise be accustomed to dealing with.
Yes.
Is that really what we're intending to do? Is to, in fact, reduce the unit of work so that it becomes more manageable?
Yes. And then you can compose these units into a larger project. But yes, the unit should be small.
2 comments. You made a comment early in your talk about that this is a group of programmers that is separated from academia and from industry. Is that true?
No, they're not separated, but the driving force came from practitioners in the field.
Because all of this stuff we teach here in software engineering, and it's called evolutionary development. Okay, I just...
all I'm saying is that this movement did not come from an academic setting. It doesn't mean that it's
The other thing is the comment he made about smallness is exactly right.
Yeah.
What you have to do is up the productivity of people so that you can take the same problem and have it be done with smaller software.
Yes, absolutely. There's a dividend to small and simplicity. Okay, working software is the primary measure of progress. If you don't have working software, your project is not clearly progressing. Of course, if after 3 months you don't have anything that works that you can demonstrate, you're in trouble. That's what it says. Of course, you don't want to overgeneralize, but that should be an indicator that something is not going right. You want an approach that is sustainable. In other words, no death march. How many projects you've seen where people have to come in on the weekend? If you want to be a real team player, you got to sacrifice your family life, and you got to pull together. Usually, when you get in a death march, no amount of time will solve it. And it's throwing more people. Well, you know what the mythical man month principle gets into play. So you want You want an approach that is sustainable. Simplicity, talked about that. Do as little as possible to make it work today. So don't really think about what's the smallest amount of work I can do to achieve my goal today, and stick to it. Learn from what you're doing is what this is about. Yes?
We also haven't mentioned a factor which is very important in this, which is the 90-10 rule.
Yes.
Which is that 90% of the functionality can be done with 10% of the effort, and that's the one you do first.
Yes. Yes. And you want to go first after the areas of greater risks as well. And we'll see that.
It's the greater risk, but
Yeah.
it's also the easiest to do.
Yes. Absolutely.
Yeah.
Agile Technologies. Well, there's a number of methodologies, and they all have in common the fact that they're risk-driven. Attack the risky areas first. Extreme programming, Scrum, rational, unified process. It's a framework so you can adapt it and make it as lightweight as you want. They all have in common the fact that they address turbulent business environments. What you're doing is as if you're doing it for the first time, and you can't predict all that's going to happen during your project. Those projects can be challenging technically, so there's a lot of risk from the technical end as well, and mostly for small teams. There's work being done right now on trying to see how to scale up XP, for example, to very large projects. Refactoring, it's another technology, and we'll go into it a little bit. It's how do you improve code without changing its behavior? You know, that's how to defeat the ratchet mindset. And there are actually a bunch of techniques, and it's cataloged. Yes?
So by XP, you mean extreme programming?
Yes.
And for the benefit of those of us who don't have that?
We'll go into more detail. I'll have a section on extreme programming. All these things I'll try to detail a little bit. And then test first design, which is a really interesting approach. When you're going to write code, write the tests first, then write the code that passed the test. You'd be surprised what the benefits are, and we'll go into more detail.
Do you use any formalism?
No.
No, because both of those things, the last two things, fall right out of using formalism.
But by formalism, do you mean?
Formal programming.
No.
You write a formal specification, very quick.
Right.
It's a formal specification of things. It tells you exactly what to test, and it also tells you where the things that are stable are, so you can write modules around them.
No, I've not seen that
I'm
promoted.
not surprised because it doesn't come out of that community.
Sure. But when you do test writing, one of the important constructs is assertions, but it's not as formal as in formal programming. But you do state your assertion.
Assertions is formal.
Well, there are assert statements in your code, and
Yeah, it's
sure.
Yeah.
Lightweight containers. Now, if you've worked with Enterprise Java Beans, that's a heavyweight container. A container basically gives you a bunch of application services so that you don't have to reinvent the wheel, and provides you a structure around with which you write your application. So there are lightweight containers. We're going to see them. Source control. What you want is shared code ownership. You're in a team, you don't want a piece of code that be only your code, and this is only my code. And you don't want also to say, well, I'm going to tell you what the API of my part is, and that's all you need to know. What happens is if you start publishing your APIs within the team, you're pouring cement over your code. You must allow anybody in the team to go and change your code. So the code belongs to everybody. And for that to happen, you have to have source control. You need continuous integration. You want always to be working with the latest and greatest of the software you're writing. You don't want someone to just go away for 2 months, do something, and come back and say, oh, here's what I've done. You want continuous integration so that every day you have a development release available to everybody. You want your tests to execute at build time so that those tests you've written, you've always written a test before you've written any piece of code to test that functionality. Well, those tests have to run every time you build the code you integrate. So it smokes out the bugs that may be introduced. And you want to do, as much as possible, some code reviews.
Question.
Yes?
Is there any organization to the teams that do this? Or are they self-organized?
They're largely, well, you'll have a project manager, but they'll be largely self-organized. You don't have any specialization.
I have exactly the same experience with evolutionary programming. It only works with self-organizing teams.
Yeah. And that's I've not mentioned it, that's a big theme in Agile, that every team is its own experience. And you can't necessarily transfer what you've learned about how one team works to another. Okay, we'll look at extreme programming a little bit more. The requirements are in the shape of user stories, short, 2 or 3 sentences that usually take no more than 2 or 3 weeks to code, produce code that satisfies the user story. You have it's an iterative development process. It's a planned process. It's not ad hoc. And you do spikes whenever you have unknowns, either unknowns about the overall architecture or unknowns about various technological problems that you detect. Because without doing these exploratory activities, how can you plan? You don't know. It's an open-ended question. So you do those spikes. You say, okay, I know how to do this now. It's going to take us about 3 or 4 weeks or 2 weeks, whatnot. Then you go and you do a release plan. And you organize it in terms of user stories. Okay, for the first release in a month, we'll have these user stories implemented and acceptance tested. Then you go into iterations. After a number of iterations, you do your acceptance test for the release, and you have the small release. You do that often. Oops. Okay. In an iteration, in a release, you have multiple iterations. For each iteration, you have a bunch of tasks. You take your user stories and say, okay, what are the development tasks that are required to fulfill each user story? And then developers step up and say, okay, I'm going to take a certain number of tasks for myself and do them. You don't let a developer take more than a certain time slot. And you go into development, and you keep metrics of what you're doing. How many tasks are being completed by the team in a given amount of time? How many user stories by the team in a given amount of time? Don't go to individual programmers. Stay at the team level. And that sets your project velocity. And now you know how fast the team is going. And that allows you to plan more and more consistently. And if you need to, revise your plan. You want to do daily stand-up meetings, face-to-face conversation. You want to do test first design. In XP, you want to do pair programming. That's one of the more controversial aspects of XP. That is, you have 2 people sitting at the same desk, and for every line of production code that will go into production, it will have been written by 2 people working together. The way I look at it, what it gives you is continuous code review. And you want to do refactoring often as well. And we'll look at refactoring in a few minutes. So that's, in a nutshell, extreme programming. It's a very disciplined approach. And it is extreme in the sense that it takes what is being detected as working, and it applies it without compromise in the mind of the people who came up with extreme programming. So that's the extreme part of it. Test first design. That's a very, very, very productive and useful practice. Again, you write the test, then you write the code. And if you find that it's difficult to write the test for a piece of code, well, rework your code so that it's easy to write the unit tests on your code. If you have a big, complicated mass of code that's in one method, and you look at it and say, how can I write unit tests? Then something is wrong. So you want to refactor your code. So you've written some tests, you've written some code, then you're going to go back and say, oh, this code needs to be better tested. I'm going to write some tests, but it's hard to test that piece of code because it's doing too much. So refactor your code so that it's easy to test, and that has a very, very positive impact on the quality of the software you're producing. Run your tests, integrate, run your tests. You find bugs. Anytime you find a bug and you fix it, write a test that goes with it. No bug fix without a test being written to accompany it. So the next time around that you make changes to your code, there's more tests already in there, and you can see if your bug fix actually got broken again. It's very liberating to do test first design. There are tools out there. JUnit by Kent Beck is one of the more famous ones, and there's all sorts of XUnit tools out there, XML unit, HTTP unit, and whatnot to test different aspects of software. And they allow you, it's a very simple framework that makes it very easy for you to write those unit tests. And then it has a little harness that lets you automate those tests. And what I like to do is to have this little test runner. I have an icon on my desktop, write a bit of test, and just click on the test runner, and then I can see if all the tests have run. The line is green. It gives you a very empowering feeling because your code does not become something obscure, something scary that if you do make a change, you don't know, you may be breaking something. There's no maybe. You'll see right away if something breaks, and what breaks is going to be a one unit test, and it's going to pinpoint the source of the problem. It's very liberating, and it's a very productive approach to doing software. To facilitate unit testing, you can use mock objects. There are some pieces of software that are hard to test, like you have a messaging middleware. How do you test that? You want to write a unit test. So what you do is you mock it. You just stub it. You create an object that fakes it. And it's very, very, it's a very useful technique. So I encourage you to look it up. Then there are lightweight containers, which make it very easy to write unit tests. It's very, very difficult to write unit tests out of container for big containers like a JV. So lightweight containers, very useful. Okay, refactoring. It's about improving the code's design without changing its external behavior. Your code is working. It's fine, except it's a monster. It's hard to understand. It's too big. You have a much better way of writing it. What's wrong with your code? Well, there's what we call code smells in it. And it's the whole diaper changing algorithm. If it smells, change it. So you have code smells like a lot of copy and paste code. We've all done that. Writing two methods. Oh, that's the same, copy, paste. That's really bad. It's a bad code smell. Or complex conditionals. If, then, else, if, then, if, else. All the way down to the right of the screen. That's another big code smell. But whenever you see them, rip them out. Refactor. Make your code simpler and easy to understand. And that has tremendous benefits. Now, refactoring is like algebra. You modify something, it has the same meaning. It's really transformations that are meaning preserving, if you want, that are behavior preserving here in terms of software. And there's a lot of these refactorings that have been identified, conceptualized, cataloged, and with a little recipe. Here's how you do them. And you can go on the web and check them out. There's support in development environments to do these, to automate these refactorings as well. So it can be really quick. You identify what you need to refactor. If it's one of the well-known refactorings and your environment supports it, you just click, 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 and it's done. So it's really worth doing. There's a great book called Refactoring, Improving the Design of Existing Code by Martin Fowler. It's really a wonderful book. Here's an example of a refactoring. You have two classes, it's object-oriented programming, that have similar features. So what you do? Well, you generalize. You create a superclass and move the common features to the superclass. That's the classic one. sometimes you've put a class as a subclass of another one, and then you realize, well, I'm doing that just to reuse a little bit of the code, but I'm not reusing the full capability of the superclass. Something's wrong here. For example, I remember in an early magazine when object-oriented programming became more popular, there was an example of how to create a subclass, and they said, okay, we have the point class, and we're going to create the circle class as a subclass of point, because a circle is a point plus with a radius. Well, that's wrong. That's the wrong because a circle is not a point. For example, a stack is not a vector because a stack has a very limited API. You want to push and pop from the stack. Whereas a vector, you can put things anywhere in the vector and remove from anywhere in the vector. So to say that a stack is a kind of vector is wrong because there's a lot of what a vector does that you don't want a stack to be able to do. But some of it you do, and that's why you think you'd be reusing some of what vector does because you want it in stack. That's wrong. What you want to do is to use delegation to say that a stack contains a vector, and then you can propagate to the vector the call to the behavior that you want in common. So if you want to, for example, is a stack empty? Well, you just delegate to the vector that's inside the stack. Well, are you empty? So you use delegation. Instead of a stack being a kind of vector, you have a stack that contains a vector. So you use delegation. And these kinds of refactoring can be done very quickly with a good tool support. So once you see, okay, I've got a code smell here, I identify what it is, it's very fast to apply the refactoring and change it. Now, if you do that, you make your code simpler, easier to understand, and it also, and because it's easy to understand, it smokes out logic bugs. Because if the code is cryptic, obscure, opaque, you don't understand what's going on, bugs are lurking in there. This brings sunshine into your code. Your code now feels malleable. You're not scared. Your code you can change all the time. It's a very, very plastic thing. It's not a problem for you to go back to code you've written before, change it, modify it, make it better without changing its behavior. It prevents code decay because your code is not obscure, so people don't make modifications that break it as easily. And if you don't have copy and paste throughout your code, you don't have replicated code, then you're less likely to get into a situation where someone modifies that logic, but not everywhere. And that's a very common cause of code decay. So you should always refactor mercilessly, and just don't ask for permission. Do it if you know what you're doing. Okay, application containers. Application containers are it's software infrastructure that makes it easier for you to build applications because they provide you with a bunch of services up front that you don't need to code yourself. Like configuration, you have all these components that make up your application, the configuration of these components, life cycle of these components, what happens when they're created, what happens when they enter into a transaction, what happens when they're being finalized, the assembly of these components, wiring them together, because a component talks to other components and whatnot. All that can be supported and largely automated by your container. Then it provides you with value-add services like security, transaction management, and whatnot. Now, if you have to write all of that yourself, you're reinventing the wheel. It's very costly. It's not a good idea. So whenever you write an application of any complexity, use a container. But use a lightweight container if you can, because it's much simpler. It's non-invasive. Your code doesn't know it's in a container. With EJBs, if you write a component, it has to implement all these methods. It knows it's an EJB component. It's a very heavyweight approach. And those containers have a large footprint. It take a long time to start up. Being a component in those frameworks is expensive. There's a performance penalty, so only big components can be made. Whereas with lightweight components, lightweight frameworks, containers, sorry, you can use just about any object can be managed by that component. And also, these objects are much easier to test, unit test, because there's no code in them that is dependent on the container, so you can test them out of container. So I really encourage you to look at the Spring framework. I think it's a premier example of a lightweight container. And you have a file where you configure your components. Then you have the code itself, and in the code there's absolutely no indication that this object here lives within a container. So it's extremely simple and non-invasive. Good books. And we'll put these slides. These slides will be available. Okay. Well, I'm fast running out of time, so I'm gonna skip. I'm just gonna mention if you should look into aspect-oriented programming. I think that's aspect-oriented programming plus lightweight components containers are bringing about, I think, something of a revolution in application development. If you're not familiar with aspect-oriented programming, let's just say that it allows you to weave into your code certain concerns like security, checking, transaction management. Imagine if you have a number of methods which access has to be controlled to. So at the beginning of every method, you say, do security check, do security check, do security check. And it's very difficult to abstract that into a common superclass. It's very awkward. But you have all this repetitious code. So you'd like to say, well, for all of these methods, we should do a security check before they're executed. Well, that's a concern. It's a concern, security, that cuts across code. It really cuts across. It's not something that can be easily generalized. So aspect-oriented programming allows you to take that code, take it out, modularize it, and say in some configuration file, okay, I want you to weave the security check code at the beginning of all these methods. But the code does not appear in the methods. It's at runtime that this weaving takes place, for example, possibly. So aspect-oriented programming allows you to take all these aspects out of your code, where they are there in a repetitive fashion, there's a code smell, put them somewhere else, and at runtime, or at compile time, or at load time, this logic gets weaved into your code and is operational. And how the weaving is done is defined in a configuration file. The important thing is that your code doesn't know about security, doesn't know about transactions, doesn't know about persistence. All these concerns are outside of your code, but they get weaved in when the code gets executed. Keeps your code very simple. You want your programs to be all about application logic. Yes?
Does the Spring framework need to run in application server?
No, it's an alternative to. It can run in an AJB server, but it's an alternative to. You have to look at it. You should look at it as an alternative. You want to build an application with a container. You don't want the AJB framework, which doesn't give you what you want and gives you too much of what you don't want. So you want to say, okay, let me try with the Spring framework.
So the application server provides some facilities to the AJB's like scalability issues like that. Where does the Spring framework take those issues from? It doesn't run in application server.
Well, it gives you, the Spring framework gives you all these wonderful declarative services that you like in EJB, like security, transaction management, resource pooling. You don't need EJBs to do that. You can have that in a framework, in a container like Spring. Now, in terms of scalability, well, people would argue that the way EJB is being used, it's actually a performance hindrance. It's actually useful only when you have true distributed business logic, and that's very rare. You can have scalability by having replication, having the same code running on different machines and kind of You can then have a round-robin approach to hitting different machines, and eventually it all comes down to the database, and that's where the bottleneck is. And you can actually get some highly scalable implementations using a container like that. People who say, "Oh, you got to use a GP because it's scalable," you got to dig a little bit deeper. That's incomplete logic. Okay. I won't tell you about the Agile development environment that we put together. It's going to be on the slides, so you're welcome to pick up the slides and
I'll put the slides up on my website. So.
They will be on Dr. Markowski's website. It's a combination of a bunch of different tools, but I won't go into it. Let's just conclude now. In a nutshell. Well, the customer is part of the team. It's not someone remote that you interact with once in a while. Your intention is to deliver working and valuable code early and often. You want to maximize conversations and minimize documentation to the strict minimum. You want joint code ownership. Everybody can access everybody's code and change it. You want to write tests first, and then the code that passed the test. You want to write this. You want to do the absolute minimum for today that will work. Don't anticipate tomorrow too much, and you don't have to, because you're going to be refactoring your code. It's a very malleable thing. So whenever new needs come about, you'll be able to modify your code and to address the new requirements. You want to integrate and test continuously. No surprises. You want to make sure whatever is written today works. I've seen projects where there's coding for months on end, and then there's a big integration, and then it becomes the integration from hell. No, integrate every day and automate that integration. What we have in the tool we didn't show you is that whenever we upload to CVS, the source control, it starts an integration process immediately, runs a bunch of reports that analyzes the code and looks for really easy to identify problems in your code. And then it runs the tests. And then it generates the reports on those tests. And as soon as the integration is done, you have a website full of reports on the code that's been submitted, the tests that have been run. It allows you to look at what your code is today with every integration. And integrations happen every time code is changed. You want to do frequent reviews. If you do pair programming, well, then you have a continuous review going on. Refactor whenever you need to, and welcome changes at any time. What's not agile? We talked about that. Long release cycles, pre-release testing, fixed requirements negotiated up front, and nothing is allowed to change later on, and so forth. What agile is not? Well, it's not anarchy. It's very disciplined. It's not ad hoc. These are well-defined processes. It's not hacking. Refactoring is really not a license to hack code. It's a very it's a very disciplined process. And agile is not a silver bullet. It doesn't remove the need for talent and experience and hard work. Finally, if you're interested, we're setting up a main Agile Development Users Group, MADOG. And you have this email address here. If you want to join in, ask for information. As soon as we have enough people, we're going to be starting meetings. Mesda is very close to announcing a home for all these user groups, a location, and that's where we'll be holding those meetings.
Maybe sometime we'll persuade you to hold some meetings up here too.
Sure, definitely. Okay, parting thoughts. Small is beautiful. Keep it simple. Embrace change. And you should really try this combo here. Test first design, refactoring, and continuous integration. Believe me, it pays off. And most of all, deliver value early and often. And if you want, you can join Madog.
Okay.
That's it. Questions?
Right, we have time for a few questions, and then we have some refreshments at the back. You guys have any? Have any further questions, thoughts?
I have a question about the unit testing.
Yes.
You said you use JUnit, and that we should write the test first,
Yes.
and then the code.
Yes.
But isn't it like when you write the test, sometimes it's dependent on the code?
Well, eventually you'll be writing code that you need to write tests to afterwards. But usually, what you want to do is say, I'm going to write the tests as a way of formalizing the requirements on the code I need to write. And ideally, you write the tests that says, okay, this is what my code is supposed to do. And then you write the code that does it. But eventually, you'll find situations where you're written a bit ahead of the test, and then you need to write the test to catch up. But try as a practice to write the test first and then write the code.
So actually, a big sort of idea is that your tests are your requirements in some sense.
Yes.
They're sort of active requirements.
They are, yes.
Do you have, at the beginning you started with some sort of stories,
yes.
War stories. Do you have war stories on the Agile side? Can you point to great successes of, Agile programming methodology?
Well, I can talk, from experience. One project I did in the early 90s, we didn't know it was called Agile, didn't know it was Agile, but for a bank in New York, where a small group wanted to do courseware for their derivative traders. But we were given a room, we're all in a room, and just next to us were the actual the client, and the domain expert was just 20 feet away from us, and we would mix in every day and talk about what we're going to do today and who's doing what, and the client would say, well, I've been thinking a little bit, and I think we should go this direction and whatnot, and we're doing in small talk, integrating our code very, very frequently. So we always had everybody's code integrated in our own, image, our own system, and this was very successful. We moved very quickly. Within a few months, we were delivering software that was being used for the training of new derivative traders. We're holding our breath, and yeah, it worked.
So you're saying they were using it before you were even finished?
Oh yes. Oh, absolutely. And it worked really well. Small team, we're always talking to each other. The client was in the same room. I mean, almost. And continuous integration. We didn't do test first design. Was an incomplete, agile experience. But I think that the most important elements were there, and it was very successful. They did a spin-off of this and made it a little business that is today flourishing. Yes.
Well, if you already use EJBs in your project, is it easy to make the transformation to Spring? Or do you have to rewrite it?
Could you just repeat the question?
The question is, if you're already using EJB in your project, is it easy to make the transition? Maybe not, especially if you've been doing a lot of the work in your coding to go around the limitations of EJB. If you've written a lot of code for transfer objects, for example, you may have done a lot of design that is specific to the limitations of EJB. It may be less work to start from scratch, or maybe take the logic of your business objects, extract it from the EJB, extract it out of the EJB weed, and create plain old Java objects with them. But it's not going to be a smooth transition, I don't think.
Okay. Any other questions? Yeah.
Yes.
Yeah. You said in it's good to minimize the documentation, but how much would you minimize it? Like, what would the important elements of the documentation be?
Well, user stories, that's documentation right there. It's a very modularized expression of what the client wants. I'd be, in what we didn't show, we would have as part of the environment a wiki allows people to collaboratively describe the intent, the important elements of design. Depends to, if you're talking documentation to developers, then you want to put as much documentation as possible in the code itself. In Java, that would be with a Java doc. And then you would want to have at least a document that describes the overall architecture of the system and how the pieces fit together, and a few UML diagrams to do that would be enough. And then have this collaborative, this wiki type tool that allows people to explain their decision and how the different pieces of code that they're writing relate to each other. In terms of formal documentation, is very little. I would say an architecture document is very important. The user stories, also describing what the requirements are. You certainly want a vision document, also describe, okay, this is what we intend to do, and we're going to do it this way, and this is why. Beyond that, it's in-code documentation. And every time you do a change to the software, it's documented in the
source.
In the source, and also the bug fixes are all documented through a bug tracking tool.
And to some extent, though, like, aren't your tests also
Yes.
a form of I mean, so you have a complete
Yes.
collection of tests which
Yes.
have comments presumably in them
Yes.
describing, something about the test. So
Exactly.
in some sense, you do actually end up with quite a bit of documentation, but it's
Yes.
not sort of the traditional big, thick
Correct.
manual,
Yeah.
but it's sort of distributed through the different components.
Rule of thumb is if what you're writing is subject to change, this should be documentation that happens in the code that is co-located where things are going to change. A vision document is less likely to change, so it's okay to put it in a Word document, for example.
Okay, good questions. Any other questions? All right, let's thank our speaker again and have some refreshments. Okay, guys.
So,
Cookies and drinks.
anytime anybody proposes something new,